Hey everybody, welcome back to my channel. This is WireDogSec. Got another video for you guys. Today's video, we are going to be covering the Junior Penetration Tester path, Introduction to Web Hacking area, and this room is the Intro to Cross-Site Scripting. Learn how to detect and exploit XSS vulnerabilities, giving you control of other visitors' browsers. Now, let's go ahead and dive into it. Task 1, Room Brief. Prerequisites. It's worth noting that because XSS is based on JavaScript, it would be beneficial or helpful to have a basic understanding of the language. However, none of the examples is overly complicated. Also, a basic understanding of client-server requests and responses. Cross-site scripting, better known as XSS, is the cybersecurity community or in the cybersecurity community is classified as an injection attack where malicious JavaScript gets injected into a web application with the intention of being executed by other users. In this room, you'll learn about the different XSS types, how to create XSS payloads, how to modify your payloads to evade filters, and then end with a practical lab where you can try out your new skills. Cross-site scripting vulnerabilities are extremely common. Below are a few reports of XSS found in massive applications. You can get paid very well for finding and reporting these vulnerabilities. So be sure to check these out if you're interested. And what does the XSS stand for? Well, it stands for cross-site scripting, as we saw above. Now let's continue on to task number 2, XSS payloads. What is a payload? In XSS, the payload is the JavaScript code we wish to execute on the target's computer. There are two parts to the payload, the intention and the modification. The intention is what you wish the JavaScript to actually do, which we'll cover with some examples below, and the modification is the changes to the code we need to make it execute, as every scenario is different. More on this in the perfecting your payload task. Here are some examples of XSS intentions, proof of concept. This is the simplest of payloads where you want to demonstrate that you can achieve XSS on a website. This is often done by an alert box to pop up on the page with the string, for example, and here it is. Session stealing. Details of a user's session, such as login tokens, are often kept in cookies on the target's machine. The below JavaScript takes the target's cookie, base64, encodes the cookie to ensure successful transmission, and then posts it to a website where or under the hacker's control to be logged. Once the hacker has these cookies, they can take over the target session and be logged as that user. And here is what it looks like here. Keylogger. The below code acts as a keylogger. This means anything you type on the web page will be forwarded to a website under the hacker's control. This could be very damaging if the website the payload was installed on accepted user logins or credit card details. And this is what that payload looks like here. Business logic. This payload is a lot more specific than the above examples. This would be about calling a particular network resource or a JavaScript function. For example, imagine a JavaScript function for changing the user's email address called user.changeEmail, open and close parentheses. Your payload could look like this, which is the following you see here. Now that the email address for the account has changed, the attacker may perform a reset password attack. The next 4 steps or tasks are going to cover the different types of XSS vulnerabilities, all requiring slightly different attack payloads and user interaction. Which document property could contain the user's token? Well, I'm assuming it's going to be this document.cookie as we saw above in this particular payload example. So I'm going to go ahead and plug this in. Which JavaScript method is often used as a proof of concept? Well, we saw above it was that alert, right? Yes. So let's go ahead and just type in alert. There we go. Now let's continue on to task number 3. We're going to be talking about reflected XSS. Reflected XSS happens when user supply data in the HTTP request is included in the web page source without any validation. Example scenario. A website where if you enter incorrect input, an error message is displayed. The content of the error message gets taken from the error parameter in the query string and is built directly into the page source. And here's what that looks like here. on the back, if you look at page source, the application doesn't check the contents of the error parameter, which allows the attacker to insert malicious code. And here's what that looks like here. See, it's going to see the source is going to the attacker controlled system here. The vulnerability can be used as per the scenario in the image below. Attacker sends a link to the victim that contains a malicious payload. Number 2, victim clicks the link and taken to vulnerable website. Number 3, link containing attacker script is executed on website. Victim. 4, the data the attacker's script gathered is sent to them. They could steal the victim's cookie, which would allow the attacker to take over the victim's account. See, I believe this is a good way to bypass MFA, by the way. Someone correct me if I'm wrong there. But anyway, potential impact. The attacker could send links or embed them into an iframe on another website containing a JavaScript payload to potential victims, getting them to execute code on their browser, potentially revealing session or customer information. How to test for reflected cross-site scripting, or XSS. You'll need to test every possible point of entry. These include parameters in the URL, query, string, URL, file path, sometimes HTTP headers, although unlikely exploitable in practice. Once you've found some data which is being reflected in the web application, you'll then need to confirm that you can successfully run your JavaScript payload. Your payload will be dependent on where in the application your code is reflected. You'll learn more about this in task 6. Answer the questions below. Where in a URL is a good place to test for reflected cross-site scripting? This should be parameters, right? Parameters in the URL. Query string is a possible point entry, so let's go ahead and take that one, plug it in here. There we go. Task number 4, I'm going to talk about stored XSS. As the name infers, the XSS payload is stored on the web application in a database, for example, and then gets run when other users visit the site or web page. Example scenario, a blog website that allows users to post comments. Unfortunately, these comments aren't checked for whether they contain JavaScript or filter out any malicious code. If we now post a comment containing JavaScript, this will be stored in the database, and every other user now visiting the article will have the JavaScript run in their browser. And here's the example here in this fancy little infographic. Attacker inserts malicious payload into the website's database, website and database. For every visit to the website, the malicious script is activated. There's the victim. The data that the attacker script gathered is sent to them. They could steal the victim's cookie, which would allow the attacker to take control over the victim's account. Potential impact. The malicious JavaScript could redirect users to another site, steal the user's session cookie, or perform other website actions while acting as the visiting user. How to test for stored XSS. You'll need to test every possible point of entry where it seems data is stored and then shown back in areas that other users have access to. A small example of these could be the following. Comments on a blog, user profile information, website listings. Sometimes developers think limiting input values on the client side is good enough practice or good enough protection. So changing values to something the web application wouldn't be expecting is a good source of discovering stored XSS. For example, an age field that is expecting an integer from a drop-down menu, but instead you manually send the request rather than using the form, allowing you to try malicious payloads. Once you've found some data which is being stored in the web application, you'll then need to confirm that you can successfully run your JavaScript code or payload. Your payload will be dependent on where the application your code is reflected. You'll learn more about this in task number 6. All right, answer some questions here. How are XSS payloads usually stored on a website? And up above here, we can see that it was talking about databases, right? Stored on the web application in a database, for example. So let's go ahead and grab database and then plug it in for the answer. All right, task number 5 here. And we're going to be talking about DOM-based XSS. DOM stands for Document Object Model and is a programming interface for HTML and XML documents. It represents the page on, or so that programs can change the document structure, style, and content. A web page is a document, and this document can be either displayed in the browser window or as the HTML source. A diagram of the HTML DOM is displayed below. So be sure to read through this, check it out. If you want to learn more about DOM and gain a deeper understanding, w3.org have a great resource. So check that out if you're interested in digging into that even more. Exploiting the DOM. DOM-based XSS is where the JavaScript execution happens directly in the browser without any pages being loaded or data submitted to backend code. Execution occurs when the website JavaScript code acts on input or user interaction. Example scenario, the website JavaScript gets the contents from the window.location.hash parameter and then writes that onto the page in the currently being viewed section. The contents of the hash aren't checked for the malicious code, allowing an attacker to inject JavaScript of their choosing onto the web page. Potential impact. Crafted links could be sent to potential victims, redirecting them to another website or steal content from the page of the user session. How to test for DOM-based XSS. DOM-based XSS can be challenging to test for and requires a certain amount of knowledge of JavaScript to read the source code. You need to look for parts of the code that access certain variables that an attacker can have control over, such as window.location.x parameters. When you found those bits of code, you then need to see how they are handled and whether the values are ever written to the website or web pages DOM or passed to unsafe JavaScript methods such as eval. What unsafe JavaScript method is good to look for in the source code? As we saw here, it's going to be this eval. So let's go ahead and plug that in there. And there we go. Task number 6, we're going to talk about blind XSS, which is similar to a stored XSS, which we covered in task 4. And that payload in that your payload gets stored on the website for another user to view, but in this instance, you can't see the payload working or be able to test it against yourself first. Example scenario. A website has a contact form where you can message a member of staff. The message content doesn't get checked for any malicious code, which allows the attacker to enter anything they wish. These messages then get turned into support tickets which staff view on a private web portal. Potential impact. Using the correct payload, the attacker's JavaScript could make calls back to the attacker's website, revealing the staff portal URL, the staff member's cookies, and even the contents of the page or portal page that is being viewed. Now, the attacker could potentially hijack the staff member session and have access to the private portal. How to test for blind XSS. When testing for blind XSS vulnerabilities, you need to ensure your payload has a callback, usually an HTTP request. This way you know if and when your code is being executed. A popular tool for blind XSS attacks is XSS Hunter Express, so check that out if you're interested. Although it's possible to make your own tool in JavaScript, this tool will automatically capture cookies, URLs, page content, and more. What tool can you use to test for a blind XSS, which is this one here? So just go ahead and copy this out of here. Here we go. What type of XSS is very similar to blind? And it said stored. So let's go ahead and put this in there. There we go. And task number 7, perfecting your payload. The payload is the JavaScript code we want to execute either on another user's browser or as proof of concept to demonstrate a vulnerability in a website. Your payload could have many intentions, from just bringing up a JavaScript alert box to prove we can execute JavaScript on the target website to extract information from the web page or user's session. How your JavaScript payload gets reflected in a target website's code will determine the payload you need to use. To explain this, click the green Start Machine button on the right, and then when the machine has loaded, open the below link. So we'll do that here in a minute. The aim for each level will be to execute the JavaScript alert function with the string THM, for example. All right, so let's wait for this machine to launch, and then we'll come back. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. All right, it wants us to enter a name here, so let's just put in whatever, WireDogSec there. There we go, confirming XSS payload. And it wants us to view page source, so let's go ahead and fire that up. Looks like it finished. It failed. Okay, and if we scroll down here a little bit, you can see hello WireDog displayed there, as they explain here. Instead of entering your name, we're instead going to try entering the following JavaScript payload. So I'm just going to copy and paste this over, and let's take a look. There we go. See how it reflected back to us. All right, now when you click the enter button, you'll get an alert that pops up the string THM, and the page source will look like the following. So let's just go and refresh it. All right, I guess we can't do that. Just click OK and just go to view page source again, just so we can see it in there. Yep, there we go. All right, so let's continue on. And then you'll get a confirmation message that your payload was successful with a link to the next level. So let's go ahead and go to the next level. All right, level number 2. Like the previous level, you're being asked again to enter your name. This time when clicking enter, your name is being reflected in an input tag instead. So if we go back here, take a look here, and there we go. Viewing the page source, you can see the name reflected inside the value attribute of the input tag. So let's go and view the page source again. And let's see what it says. Hello. Yep, and there we go. The value equals WireDogSec. All right. It wouldn't work if you were to try the previous JavaScript payload because you can't run it from inside the input tag. Instead, we'll need to escape the input string so the payload can run properly. You can do this with the following payload, so let's go and do that. And it says the important part of the payload is the double quote greater than sign, which closes the value parameter and then closes the input tag. So let's go ahead and try this again with this new payload here. All right, we've got our payload ready to go. Make sure you have all your less thans and greater thans in there correctly. Hit enter and it's reflected back to us. There you go. Now let's see what it does here. Successful. And if we go and look at the view page source again, and you scroll down in here, you can see it's running the payload right there. So let's X out of this and let's continue on to level 3. So you're presented with another form asking for your name, and the same as the previous level, your name gets reflected inside an HTML tag. This time, the text area tag. So let's go ahead and do that. There we go. We'll have to escape the text area tag a little differently from the input. From the input one and level 2 by using the following payload. So let's go ahead and copy this out of here. And it says this turns this, which is what it currently looks like, into this here. So if we just go take a look at the future page source real quick. Got your name here, and there's my name there. Now let's close out of this and try it with this payload. Everything looks good, so let's go ahead and reflect it back so we know it's running. And now if we go take a look, view page source here, we can see it's now here. The script is run. The important part of the above payload is the closing the text area tag, which causes the text area element to close, so the script will run. Now, when you click the enter button, you'll get an alert pop up with the string THM, and then you'll get a confirmation message that your payload was successful with the link to the next level. So we already did that. Let's go ahead and continue on to level 4. Enter your name in the form as usual. You'll see reflected on the page. This level looks similar to level 1, but upon inspecting the page source, you'll see your name gets reflected in some JavaScript code. So let's go ahead and take a look again at view page source. All right, so if we take a look here, we can see this .inner.html equals WireDogSec. All right, you'll have to escape the existing JavaScript command. So you're able to run your code. You can do this with the following payload. So I'm going to go ahead and just copy this out. What you'll see from the below screenshot will execute your code. The single quote closes the field specifying the name, then semicolon signifies the end of the current command, and the // at the end makes anything after it a comment rather than executable code. So let's go ahead and try it with this new payload. There we go. All right, now if we go and take a look at the page source again, and we're scrolling, there we go, inner HTML, and let's continue on to level 5. Now this level looks the same as level 1, and your name also gets reflected in the same place. But if you try the following payload, it won't work. When you view the page source, you'll see why. So let's just go ahead and try it out and see what we can find here. All right, payload failed, view page source. Okay, we can see it here, but as you can saw, there was nothing like reflected back or anything, right? And it says that the word script gets removed from your payload. That's because there's a filter that strips out any potentially dangerous words. When a word gets removed from a string, there's a helpful trick that you can try. So close out of this. Original payload is what it looks like here. Text to be removed by the filter, which is script. Final payload after passing the filter. Try entering the following payload here. So let's try this. And then click the enter button. You'll get an alert pop up that it was successful. And then continue on to the next level. So let's go and do that. All right, now if we go ahead and just take a quick look again at the page source. I mean, it still looks the same, right? But this time we got it reflected back to us. And the script tags are there. So there you go. Now we're going to go into level 6 here. Similar to level 2, where we had to escape from the value attribute of an input tag, we can try the double quote greater than sign with the following payload, yada yada yada. But that doesn't seem to work. Let's inspect the page source to see why that doesn't work. So once again, I'm going to copy this payload out and see why it's not working. All right, payload failed. View page source. And let's see if we can locate it real quick. And this looks like it here. You can see that the less than and greater than characters get filtered out from our payload, preventing us from escaping the image or IMG tag. To get around the filter, we can take advantage of the additional attributes of the IMG tag, such as the onload event. The onload event executes the code of your choosing once the image specified in the source attribute has loaded into the web page. Let's try, or let's change our payload to reflect this. So let's go ahead and copy and paste this. Now we have the onload equals in there. And then reviewing the page source, you'll see how this will work. So close this out, and then let's try this again. There we go, reflect it back. Payload, and there's the flag for that. Let's take a look at the page source real quick. And there you have it. Download equals, there you go, the alert. So let me just grab this flag real quick. And let's continue on. Now, when you click the enter button, you'll get an alert pop up with the string THM, and then you'll get a confirmation message that your payload was successful. With this being the last level, you'll receive a flag that can be entered below. Polyglots. An XSS polyglot is a string of text which can escape attributes, tags, and bypass filters all in one. You could have used the following or the below polyglot on all 6 levels. You could just complete it and it would have executed the code successfully. Oh, that's awesome. Really cool. So be sure to look into these polyglots. Maybe that's something you guys can use. Let's go ahead and enter this flag in, and then we're going to task number 8. Practical example blind XSS. For last task, we will go over a blind XSS vulnerability. Ensure you terminate the previous machine and then click on the green Start menu, or machine button at the top. Right, load Acme IT support website. You'll need to use attack box, yada yada yada. Okay, page is loaded up. It wants us to click on this customers here and then sign up here. And let's just go in WireDogSec test at email.com. Password 123. There we go. All right. Now let's continue on here. So yeah, which is the feature we will investigate for weaknesses. Try creating a support ticket by clicking the green Create Ticket button. Enter the subject and content of just the word test, and then click the blue Create Ticket button. All right, so let's go ahead and do that test, and then what's it wants, I guess, test in here as well. Notice that new ticket list ID number, which you can click to take you to a newly created ticket. Like the task 3, we will investigate how the previously entered text gets reflected on the page. Upon viewing the page source, we can see the text gets placed inside a text area tag. So let's just go ahead and do this here. All right, okay. There's the ID number. All right. And it says we just want to view page source from here. And if we scroll through here, you can see the text area stuff here. Yep, there we go, test right here. So there we go there. Let's now go back and create another ticket. Let's see if we can escape the text area tag by entering the following payload into the ticket content. So let's go ahead and do this here. And we want to create a new ticket. So create ticket. And let's see. All right, so let's just do this test 2 and then contents, create ticket. Okay, now if we go into it, yeah, it's outside that box there. All right, now if we go back and view page source again, take a look at it from here, you can see there's the test and text area tags they're talking about here. Again, open the ticket and viewing the page source, we successfully escaped the text area tag. All right, so let's go ahead and continue on. Let's now expand on this payload to see if we can run JavaScript and confirm that the ticket creation feature is vulnerable to an XSS attack. Try another new ticket with the following payload. So let's go ahead and just copy this out of here real quick. Just going to call this test 3, plug this in here. Now, if we click it, there we go, reflect it back to us. Now, when you view the ticket, you should get an alert box with the text string THM. We're going to now expand the payload even further and increase the vulnerability's impact. Because this feature is creating a support ticket, we can be responsibly confident that a staff member will also view this ticket, which we could get to execute JavaScript. Some helpful information to extract from another user would be their cookies, which we could use to evaluate or elevate our privileges by hijacking their login session. To do this, our payload will need to extract the user's cookie and exfiltrate it to another web server of our choice. Firstly, we'll need to set up a listening server to receive the information. Using a attack box, let's set up a listener using netcat, old reliable netcat. And let's type in the following here, -L -P 9001. There we go. And it says the -L option indicates that we want to use netcat in listen mode, while the -P option is used to specify the port number. To avoid the resolution of host names via DNS, we can add the -N. Moreover, to discover any errors, running netcat in verbose mode by adding the V option is recommended. The final command becomes this following one, equivalent to this. All right, so let's just close this and use that last command there. So it was netcat dash, I usually just put LNVP. There you go. And then 9001. All right, now let's go ahead and continue on. Now that we've set up the method of receiving the exfiltrated information, let's build the payload. And this is what it looks like here. It's very long. Let's break down the payload. You got the closing text area tag. Tag closes the text area field. Script tag opens the area to write JavaScript. Fetch command makes an HTTP request, URL, or IPs, either the THM request to capture URL, your IP address from the THM attack box, or your IP address on the THM VPN. And be sure to pause the video and read the rest of yourself here. Now create another ticket using the above payload, making sure to swap out the URL or IP port number variables with your settings. Make sure to specify the port number as well for the netcat listener. Now wait up to a minute and you will see the request come through containing the victim's cookies. So let's go ahead and do that real quick. All right, so let's just do this hacked. There we go. And let's go ahead and paste this payload in here. And we're going to replace this information. Go ahead and close this out, 9001. Now everything looks good. Go ahead and create ticket. And then we're going to view the ticket. Let's see if it worked. We got something back. There we go. There's the cookie. And it looks like base 64 encoded. So we're probably going to use base 64 to decode it. All right. So there is the staff session cookie, and let's see if it just needs this information here. So just copy this out, copy and paste. There we go, folks. Now, that pretty much wraps up this video. Hopefully you found this informative, and if you're new here, please consider hitting the subscribe button with the notification bell so you know every time I post. Hit the like button if you're enjoying the content. Comment below your thoughts and opinions on the information shared. Have you ever found an XSS vulnerability? Are you interested in digging and learning more about XSS vulnerabilities? Anyway, thank you all for watching, and I will see you later. Have a nice day.